And we're back with another problem that we need to sort out. This is forces on incline. In this problem we have a block and we notice that it's on an incline. We have to consider friction on the incline, and we also have a force probe that would be reading the tension. So what we want to know is what is the force of friction between the block and the ramp, and then what is that force of tension. So let's start with a free body diagram. So if we think about this, the force normal and force gravity perpendicular will balance each other. The force of gravity parallel will be down the ramp. Then there are going to be two forces opposing it in this case. There would be the force of static friction between the block and the ramp, and then there would also be the tension. So we need to sum those two. So if we start by finding the normal force, and this will help us find the friction, that would be equal to the force of gravity perpendicular, which is mg sine theta. The force of gravity parallel is mg sine theta. Then the force of static friction would be the coefficient of static friction, which is given to us in the problem, and then the normal force, which we found above. So this would be our expression for that. Then force of tension is unknown. So let's write a net force expression. The net force in the direction parallel to the ramp would be the sum of the three forces that we mentioned. Let's call the forces leading up the ramp to be positive, and then the forces that would have the block accelerate down the ramp be negative. So that's why we set those signs. Then we know that these all sum to 0 because it's currently not accelerating. Rearrange for the tension. So then the tension would be given by the difference between these two, the force gravity parallel and the force of static friction. Okay, then we can plug in what we found above. We realized that we could use the components of the gravity force in this way. So this would be force gravity parallel. This would be the static friction force. Then we can factor out an m and a g. So do that, and that will make the expression a little bit simpler for us. And that's all we need for this problem.